make sure the laptop doesn't die.
Yeah, most of you probably know me. I'm Jeff. If I don't know you already, I'm Jeff.
Hello,
Right?
Jeff.
And Jeff is, tell them the interesting thing about your ASF affiliation.
Oh, yeah, I should say that. I am the chair of the Apache OpenNLP project. And so this work has been going on for a few years to get some stuff in Solr, and we're excited to share it.
Exactly. Yeah. So this talk's maybe a little different than some other ones. Both of the next few talks are going to be a little different than the other ones because they may not be quite as polished and more of a conversation and what's going on. And I guess we go to slideshow. I guess so. Although, do you know what your next slide is?
No, I don't.
No. So then let's not. Can you guys see that? Is that big enough, or do we need the slideshow mode, David?
Why? One of my pet peeves is people not being in slideshow mode.
Okay,
With that being said,
solved.
is there a point to it though? Like, is there a value? Like, why did you even ask?
We're just kind of curious what our next slide is. So, so we're just going to go ahead.
If there are
and
notes,
hit
then
it.
please.
Next slide is right here on my phone. So how many people have already seen this talk? I can't remember if we did this at one of the earlier Apache cons. So, the origin of this story was Jeff actually went to the very first, there's a couple of OpenSearch people around, you went to the very first OpenSearch conference, and you talked about using OpenNLP and extracting and integrating with Onyx models, right?
Yep.
And that. And then he wrote some code. And then you gave a talk at one of ApacheCon or something, Community Over Code, about Solr.
Yeah, something like that.
And that was an interesting talk. And then in Halifax, we had sort of an unofficial hackathon, or we had a hackathon. Yeah, that was the first one. It was we organized it on the fly. And I was super curious about that, and Jeff brought had the code, and we updated it for whatever the current version of Solr was. That was a 9 at that point, right? And then David gave me a ride home all the way to from Halifax to Bar Harbor. He gave me a ride home. I gave him COVID. Maybe not the best sign of friendship or community collaboration, right? But that is what happened. But on that on that 8-hour, 7-hour ride in the back of David's Tesla, I got it all finally working with a BATS test. So this is sort of Solr-centric. BATS is the Bash Automated Testing Script, and it's useful for testing complex things. And we actually got it working by the end of that trip. This ability has been sitting out there, though, for now 2 years since that conference. And the reason is this new capability that we're going to show, and I'm alluding but not talking about, required a perfect confluence of OpenNLP being released to support Onyx models and NLP models. It required Lucene to update because Lucene depends on OpenNLP, maybe in Sandbox, maybe in Core, I can't quite remember. It required Solr to update its dependency of OpenNLP, and it required Solr to adopt Lucene 10 so that it could have the whole hierarchy, right? So this code's sort of been sitting out there for 2 years while we waited for all of the various dependencies and releases to catch up. And that really happened only a couple of months ago when Solr got to the 10. It was as like committed to main, and that was super exciting. I looked one day, I'm like, oh, I guess we're there, right? So yeah, so this is kind of telling that journey and story. All right,
Yeah.
I think you're up next, Jim.
Yeah, he left out the part about once all the versions got up to date, I had to go back and fix everything that was broken in OpenNLP.
Yes, and get a release
Yeah.
of that.
So OpenNLP, real quick, machine learning framework, Apache, it's more the classical approach to NLP, not the LLM type stuff. Fast without a GPU, cheap, efficient, should not be ignored in today's LLM world. If you caught my talk a couple days ago, I preached on that about 40 minutes. It was a blast. Performance can be on par with newer methods, so again, don't overlook it. And we got a healthy user and developer community, and so you know, activity might seem slow at times, but we are active. There are people using it. It's not dead by any means, or even close to it. So some history. to give you the big picture, Eric gave you some of it. We'll go back a little bit farther. So OpenNLP started around 2002 on SourceForge. 2010 joined the Apache incubator. In 2011, there was a ticket to integrate OpenNLP and Lucene. And you see there's like a big gap there. 2017, that ticket got resolved. So 6 years later, we got OpenNLP and Lucene. And then a year later, Solr 7.3 included the OpenNLP update process. So now you can do named entity recognition right from your Solr.
Parts of speech too?
I think so.
Parts of speech, there were a couple of models in there.
Yeah, but then we got this green box between 2018 2022 where the NLP world kind of flipped on its head. Everything changed. And then so in 2022 is when this work started that Eric was talking about that took 3 years or so to get here. Kind of kicked off with the release of OpenNLP 2.0. So the motivation, that big gap between 2018 and 2022, what changed? Okay, some things changed. Okay, a lot changed. Okay, practically everything changed in NLP. I mean, just everything went upside down. Deep neural networks took over. Before then, like a lot of NLP was OpenNLP or Stanford Core NLP. All of a sudden, it became PyTorch. It became Python. And as much as you might hate Python, I don't hate Python. It's just like, here we go. It's going away. Embeddings, new state-of-the-art results just came in, and stuff just got flipped on its head. So here I am thinking, well, what does this mean for OpenNLP at this point? You can see your users. Even though people are still using Java, there's still NLP needs in Java. What are we going to do? So here's a picture. OpenNLP on the left with its single layer perceptron algorithm. I think of it as like that old trusty Toyota Ford truck. It ain't gonna blow up. It'll get you there. It might get you there in 3 days, but it'll get you there. It's reliable. On the right, we had Hugging Face transformers with the deep neural networks and the rocket ships. Right, it does all the cool stuff. But we need some way to bridge this. So. Solr down there in the bottom and other stuff, that OpenNLP is in. Wants to take advantage of this newer stuff too. What can we do? What is this bridge going to look like?
Mm-hmm. For those who don't use NLP every day, would you mind just briefly mention an example or two of how some search engine might want to use it?
Sentiment analysis. So sentiment analysis is a great one, right? Let's say we have comments that we're gathering, right? People are supplying comments. We only want to search over the positive comments. Okay, which of the comments that we have are positive and negative? That's called sentiment analysis. You take the text, you bounce it off a language, you do natural language processing, and it tells you, yes, that's a happy sentiment. That person was happy about whatever was in that comment, or that person was angry or frustrated or negative, right? You might want to only search in your e-commerce solution over the positive ones. You might sort products in e-commerce by the ones that count of positive comments, and you might discount the products that have lots of negative comments. That's maybe even a better example.
Named entity recognition, pull people's names out of long text, searching, stuff like that. Yeah. So
does it require a dictionary though? Does that require a...
No, that's the natural language processing, right? Understanding language well enough to understand those are names, those are places. So,
so one good solution for this, after I looked over a bunch a few years ago, was using the Onyx runtime as that bridge. So to bring the Java OpenNLP with the Python cool stuff and the cool models, the Onyx runtime was able to give us that bridge. And so, quote straight from the Onyx the website there, you can read it, open source, high performance inference engine that executes machine learning models in the Onyx format. So you can take models in, trained by PyTorch or whatever, and you can convert them over into this standardized format called Onyx, and then you can run those on different places. And it does optimization, other stuff for you, different architectures, really cool technology outside of this talk. It's useful.
Came from Microsoft Research, was that right?
Yeah.
And it was basically acknowledging that one side of the world uses one set of technologies, Python and that, and then the other side of the world, they're .NET, they're Java, they're whatever, and they needed a way to talk to each other and share these models together, and it's pretty cool.
Yeah. So now the pictures, we can have our Hugging Face model, get the model converted to the Onyx format. The Onyx runtime is what we can use from our Java code to then use that model.
And for those, everybody familiar with Hugging Face, you've heard about it. It's a repo for all of these models. There's something for everything up there. It's quite astonishing.
Sure is. So now we don't have our trusted Toyota, and we don't have a rocket ship. We got a combination of the two. We got a truck that's somehow a rocket ship on the ground, right? So we got our OpenNLP, and through the Onyx runtime, we can take advantage of these deep learning models off of Hugging Face. So now we can go to Hugging Face, and we can look for a model, and we can say, oh, this is what we want. Let's download it, let's convert it to Onyx. We can now use it from our Java applications. And in some cases, I think I have a slide here somewhere, not that one, you don't even have to convert it. Onyx has become more popular now, and for some models, there's just the Onyx already up there. You can just grab it, so it makes life a lot easier. I want to talk a little bit about using the Onyx runtime from Java, to give you a little into the nuts and bolts of how it's implemented in OpenNLP. So when you download an Onyx model, you got to know how you want to interact with it, or how you do interact with it. And a really cool app to do this is called Netron. Go to netron.app in your web browser. You can give it the path to your Onyx model local. It all runs local, and it'll show you a screen like this. And this screen is kind of like the Rosetta Stone for how to interact with that model. You'll see I have the inputs and the outputs. That tells you right there. Using the Onyx runtime, these are the inputs the model's expecting, which are called the input IDs, the attention mask, and the token type IDs, and then the outputs. And the outputs is an array of probabilities. So the input IDs are your tokens. So from your vocabulary that the model is trained on. So you just tokenize it, get the IDs, put them into an array. The other two arrays, attention mask and token type IDs, we're really lucky, they're all just ones. There's some things in life that are just like, oh, that's nice. They're all just ones, because attention mask means 0 or 1. Do we want to pay attention to this token? Yeah, we want to pay attention to all the tokens in this case. So they're all ones. And token type IDs is also a binary 0 or 1. And it allows you, for some models, like question and answering, has two different segments. The question and the answer. And so the 0 and 1 allows you to say, 0 is the question, 1 is the answer. We're not dealing with question and answering models here. We're dealing with sentiment, named entity recognition. So we have one segment. So they're all just ones. That's so nice. So we pass in the IDs from the vocabulary and just all ones for the other array. And Netron tells us that the model gives us back an array of probabilities. Fantastic, right? And so in that array of probabilities, each one is the probability of each label for each token in the input. So it gives me back this array of 9 boxes I might have, and then the labels under it. And this uses a biocodec, codec before inner, outer for the arrays, meaning a token like B-PER, that fourth one over, you can see it's little, means before person. So that's like where the person entity starts. And then I-PER is like the inner person entity. So before might be George, the I might be Washington, or the name George Washington. So that's just how it denotes what an entity is. I got a better example here for you. So these labels, you're like, okay, where do these labels come from? This model is giving me probabilities of these labels. Where are these labels from? These labels are from how the model is trained. So each model on Hugging Face or wherever you get it should have a config file, config JSON file most often. And if you look at that file, it'll tell you the labels. There they are. ID the label, 0 through 8, 9 of them. There's the labels. Those labels are what correspond to that array, what we just saw. So those are the probabilities of each one of those for each token. Probably sounds complicated.
It does sound complicated.
It's not.
I think it's great if you're a data scientist or a machine learning person, but if you're a Java coder
It's super
building
easy.
apps focused on meeting a deadline,
Super easy. So here you go. So let's say we gave it George Washington was president as our input array. Here's the outputs, our probabilities. So for each word, George Washington was president, you see the boxes across. The red box is the highest value. That means the model is saying George is a beeper. Beep. So before person, George. And you see Washington is marked as inner person. So it's saying George Washington is a span of a person. Was president, the red boxes are on the far left for O, meaning they're nothing. They're not what we were looking for. Perhaps if we were using a model looking for verbs or looking for regular nouns, then maybe those would have been something. It's not what we were looking for, so the model said, no, these aren't parts of a person entity, these are zeros or O's.
Did you say these are probabilities? So since there were one, like greater than one, I'm missing something, like 3.4,
Yeah.
3.4, and so on and so forth.
What is the magnitude, in other words? Okay.
it's not a 0 to 1, I think, is what.
It might not be bounded, upper bound at all. So probability is probably not the right word for it.
Okay.
Yeah, good call out, thank you.
Well, anyway, the documentation would probably say on this model like what it means
Yeah,
to do with it.
Well, there is some good news if we get a little further.
It might be a measure of the probability rather than the probability itself.
very possible.
Yeah.
Yeah, thank you. I'm gonna have to look that one up. So we need a model in the Onyx format to do any of this. Converting it is easy. There is a CLI tool from Hugging Face, optimum-CLI, export Onyx --model. You give it the name of the model on Hugging Face. So like look at the URL, look at the Hugging Face, just type it in, it'll do it for you. The task, image processing, it's not what we're doing here, just an example. But that will take that model, it'll download it for Hugging Face, run your command line, output the Onyx model, you're good to go for that. Or a lot of models now are already in the Onyx format because it's become more popular. So just
We found this out 2 weeks ago.
Yeah.
I was like rerunning the thing and it wasn't working. And Jeff was like, oh, that's because the model you're looking at is already in the Onyx format. So I was Onyx encoding an Onyx model and that didn't work.
Yeah.
So that's like how Onyx over the last couple of years is becoming more common and popular, right? Is that now people are just shipping their models in that format because it's doing, I think it's doing a good job of becoming a lingua, a standard, one that everybody uses.
yeah, so just take a peek in the file list on Hugging Face and see if there's already Onyx in there. Cool thing, model training is done outside of OpenNLP. So OpenNLP can train its own models, of course. That's how I used to have to do it. But for this, you don't have to do that. This doesn't interrupt your workflow of training your models in your Python environment like we always do. So you can still train them using PyTorch or whatever your favorite tool is, get them in the Onyx format since it's becoming a standard, now you're good to go. So I think that's a really cool point that you don't have to change your model.
That's like the big win, right? If you've ever worked with data scientists, right? Data scientists, they want to make models, right? That's what they like to do. And they're not going to come join us in our Java-centric engineering world. They're going to be over there doing their feature engineering, all the rest in their world, right? And we've struggled to come up with ways of taking their work, and they're always like, I'll stick up a Flask app with a quick API, and you just call that a million times, right? So I think that this offers a nice way for each community to use the tools that it wants to use.
So now this brings us to today.
Yes.
We can now use Onyx models. I should not say now. We can soon use Onyx models in our Apache Solr search engine via Apache Lucene, via Apache OpenNLP. So it's Apache all the way down. And this is an example of update request processor. So I mentioned the update request processor was added to Solr for OpenNLP in like 2018. That was used in the old traditional OpenNLP models, which you can still do today without any issues. It's there. Now there's one, OpenNLP .cat update processor factory, and it takes in the Onyx model file path, the path to the vocabulary file that was used for training the model, and the fields, the source, the overview, and where you want to put the output of the model. So in this example, we're going to do sentiment classification on the text in the overview field when documents are being indexed, and write that sentiment, whatever it might be, into a field called Onyx_classification.
So the good news is, right, so he showed what he was comfortable with, which was zeros and ones and probabilities in George Washington. This is what I'm a lot more comfortable, which is a fairly simple configuration where there's the model. I'm not touching the model, that's standard. The vocab file, I get it, download one. I can tweak it a little bit if I want, but I'm not doing data science-y stuff. And then, of course, my good old, I have a field. I don't know why we didn't call it overview_classified or sentiment. That might have been a better title, right?
I'm horrible with naming.
Yeah, but this is like the environment that those of us who've worked with update request processors are super comfortable in, and we use all the time. So.
I think this is like the exact same slide with just a sentence at the top. So yeah, let's just.
Yeah.
And here, just point it out. The same slide 3 times, right? This one's got arrows. The
It's
model.
because we didn't have our preview.
The vocabulary
Like-
file, the field to classify, and the destination
Yeah.
schema. All right. The next one is not the same slide. Okay.
So you see, right? We actually, so this is what our vocab file dumped out. No, or is this in our Java code?
Which
Is
part?
that very bad?
Very, very bad is from the model. So
Yes.
the sentiment model was classified, I think, in 5 categories, like very good, good, neutral, bad, and very bad.
Yeah. And so that's where we're getting that from. So, and that, could it have been a number?
Yes, it could be.
Yeah. So one of the things I do want to point out is that when Jeff wrote this OpenNLP document categorize and update, so he was saying that there is a class of models out there that do document categorization, and this one was designed, remember, for those inputs and outputs, right, that he looked at. This one is designed for any of a whole set of models on Hugging Face that all have that input output. If you wanted to do something different, like question answering or something else, right, well, that's an opportunity to contribute a different OpenNLP document, whatever, that understands those inputs and outputs, right? But we were trying not to expose everything in Onyx to you as the application developer or the search engineer. We wanted to wrap those and expose the things that you would care about.
Yeah, absolutely. And fun fact, the very bad, I did this on horror movies, and all horror movies it said were very bad based on the description.
Does this processor specifically do sentiment analysis today? Does this update processor specifically do sentiment analysis today?
No, it does document classification, but this model is for sentiment analysis. So you could use any document classification, like spam or anything else, and
it would work.
Yeah.
So the output of this depends on the model and not so much on OpenNLP.
Correct.
Yes.
Okay.
Exactly.
OpenNLP is just kind of helping you, right? But the model you pick does within this category. This one will work with this category. We imagine that there will be others that work for other categories of Hugging Face modules, right?
Exactly. Yeah. Sorry.
So the name of the OpenNLP .cat update processor. .cat is document classification.
Document.
Categorize.
Okay.
Yeah. We're not classifying these documents. We're categorizing.
The output is not
Yeah,
classification.
naming. Yeah, naming.
Are we doing questions? Sorry.
No, sure.
No, yeah.
Are these files, these model files, are they on disk, or are they in
Ooh, can't wait to show you that, because we also got lucky that Solr had matured a little bit. And in a moment, I'm going to show you how you get those model files in.
Yeah, I guess.
But anyway, back to your question. Yeah, so if you had like a span model, your output here could be span or not span, could be anything.
Yeah.
Cool stuff. All right,
Okay.
so
I just had an idea as I was thinking NLP, and I'm not used to using this stuff. It occurred to me that maybe possible use of OpenNLP maybe could be as imagine you're in e-commerce and you're trying to maybe extract out the noun maybe from a product description in a general way. Maybe this could be used to pull out the most prominent noun if there's a model that does that, and therefore maybe boost on that.
Yeah,
Absolutely.
totally.
Okay.
Exactly.
Yeah.
And what I'm excited about this is we're not building a whole parallel system out there that is a whole separate team that the search team has no influence over. They do theirs. We actually can go do those because we're looking at messy content anyway. Why not use the tools we already have?
Another question. That final very bad that you showed in the Solr document, is that from the config.json label, like within the model? Is that,
Exactly.
Okay.
Yeah. So, yeah, you could imagine doing something to map them to other things as well, but this is where we are in this. So,
yeah,
we're showing
so
this. We have how many minutes? 5?
413, 350.
How much?
310.
3:10 we started, right?
Right, so we have
12
Well,
minutes.
12 minutes. Oh, good,
So you
good,
guys
good.
get 1 minute.
Okay, all right. I wasn't sure if I was like needing to rush.
After that, you're between the other snaps.
So, excellent.
Yeah, quick.
So,
So I just want to show the code on in the OpenNLP side. The stuff that I showed with the arrays earlier, it's really not complicated. I mean, I did, guys, I did. So it can't be that complicated, right? So this is just showing putting those tensors, those arrays together in the Java code to call the Onyx runtime. And that second line, I'm putting in the token IDs for the vocab. And then the second and third lines are just setting all the intention and the types to just one. Calling session.run, which is doing inference using the model, gets back that three-dimensional array of the labels and the scores, probably the scores for each one. So it's not super complicated to do. Didn't want that to feel intimidating or anything. Now, on the Solr side.
all right. So this is the PR that's out there. Let's go. So this is the PR that is out there. And I wanted to show you the model aspect of it, right? So started a while ago. This is after I inherited the code from the first version that Jeff wrote. And, you know, those of you who know me know that I like to use BATS tests for everything, either good or bad, but test OpenNLP.bats, right? And so this is literally a test that we're running as part of our CI process. This model, it's 166 megabytes is I think what it was, right? It's currently deployed on our nightly. I didn't know we actually could do that now, but one of the other, Richard Zawala from OpenNLP made this change the other day, thank you. And so you grab that, and then you grab whatever, the vocab. And in Hugging, these are just, well, there they are. That's the Hugging Face equivalent, but we didn't want to depend on that. And, you know, all of these models out there, they have the model and a couple of supporting files, you grab them. Okay, I've got that, yay. Now, scrolling on down here, there's my startup, right? I'm giving Solr a little extra money. I'm enabling the analysis extras. That's where this code lives, right? It's a module. You do have to opt into it. It's a extra analysis, right? Makes sense. Not totally sure why we're enabling packages in this. Not sure. We go ahead and start it, and we create.
If you're using the file store, you need to enable packages to use the file store. That's probably why you're.
That would be why. So what I want to point out, right, is I'm going in here and I'm just creating a collection, right? So I created a collection called col_name. I'm going ahead and adding a field, right? This is just standard plumbing, name and name underscore sentiment. I made it a string value, okay? So standard stuff. Now this was a nice win right here, which is I'm literally grabbing the vocab file and I'm sticking it into the file store, right? And I don't know how many of you all have ever used it, but it's cool. It's a distributed file store that you can stick in there. And as of Solr 10, it's the only distributed file stores. Is that true, right? We used to have 4 or 5, and now we're down to 1. That's nice. And I'm also sticking that 166 megabyte file. Under the covers, it distributes it around the cluster, and they live on disk, not in Zookeeper, because I know someone's going to ask that. And then we get to use our standard APIs, right? Add, update, processor, sentiment. There it is. There's a document categorizer. I think our example has a different, we have a nicer name here than in our slides. Yeah, see, we have a nice pretty name right there. And there we go. Okay, so I'm gonna do 2 documents. ID good, name that was an awesome movie. ID bad, name that movie was bad and terrible. We'll go ahead and stick it in. And notice we have the sentiment classifier turned on we just added it as a processor on the query parameter. And we say commit. And so it runs through, and let's go look up, right? And there's my assert. I'm looking for the document with the category good, and hey, look at that. Name sentiment was very good. That's what we expected. And I look up the bad one, and name sentiment was very bad. So that's it. So does that answer your question about the model? I mean, it's...
you're storing out the file system.
Yeah, but super easy that I don't need local access, I don't have to muck around, it was just so nice. And what this means is it's also very easy to play with lots of different models, right? Lots of different Hugging Face models, so So that's all the good news. One thing that we have not solved is the version of Onyx or the version of Onyx that we're using is the CPU version, not the GPU version. So we haven't thought about that. What else have we not thought about? We haven't really. Not sure on those. What are those first 2 bullets there, Jeff?
Yeah, so on the OpenNLP side, you can do Onyx for document classification.
Oh, I see.
name,
Yeah, we only have this one
recognition.
example, right?
OpenNLP, I want to build out more NLP tasks using more models, not just those 2 tasks, and then make those available through Solr and through Machine and Solr too.
Yeah, and then on the Solr side, and in this, we haven't really come up with a good story about CPU versus GPU, right? Right now, we just use the CPU for the OpenNLP stuff. There's no smart stuff about where that goes. So,
yeah, OpenNLP supports GPU for it. I don't really know what happens in Lucene out there. Probably something we need to check out.
yeah.
Here's my question actually, like what is the relation, I understand the relationship between OpenNLP and Solr, I'm seeing that, but what is the Lucene connection?
Lucene uses OpenNLP for something under named entity. It uses those older OpenNLP named entity recognition
They're
parts of
filters.
speech.
They're analysis, like part of the analysis package.
Oh,
Yeah.
okay. The analysis. Oh,
Yeah, like lematization.
filters.
Let's say you have an inflected language, how they're inflected, and
So-
you have lexical matching.
I see.
That kind of stuff.
Anyone think this would be cool? Anyone see a use for it?
Oh yeah.
Awesome.
Well, that was not a code review.
Bravo! It took a couple of years. It's now available in Solr 10. Complete with Hugging-based models.
What kind of code reviewer? I didn't even know.
You call it click approve?
So, yeah. I was waiting for you to scream, David. But the change log, you forgot to put a nice commit message. I did. We can rewrite it. So, all right, that's our talk. Thank you guys very much. Yeah.
So you use the file store to reference the model files in the vocab file.
Can you use a relative root? Yeah.
Okay. Can you use other things? Can you use use a network-mounted drive or some other
I don't
thing?
know. It's just
SCD
a relative
maybe?
relative path. I don't know. I assume so.
No, last time.
Because like when you deploy a model like and it fails on one node, is that like transparent? Will it like with Zookeeper?
I think
It
that's
will.
a great question. You should go check your OpenTelemetry stats
I don't know.
and see what they say.
That's a good question. I don't know. I think it was a basic. I briefly code reviewed the design of the file store. It's a basic.
Okay.
I think ideally, if you control the Docker image or the Solr distribution, I think you might be best served by getting a model out that way. But that being said, if you have a cluster that's running somewhere and want to,
Yeah.
it's an alternative. I think there's multiple ways to get there.
I think it's good to have an alternative. Zookeeper has its own problems, but it's
Yeah.
like more like
Yeah.
that's a solved problem. Zookeeper, but and uploading big files to Zookeeper.
Right.
Yeah,
See,
It's
that's
a pain.
Yeah.
Yes.
I was floored that it worked when I shoveled a 166 megabyte file. Like, I was like, oh, we did have to do some stuff. For a while, it would store it all in memory. Like the API would read everything into memory and then write it all out to disk, and we had to make that streaming. That was an early whoopsie. I think that's why it would work if you gave Solr enough memory. You could put big models in, but it did store them all in memory and then write them to disk, and so we had to fix that. And we haven't tried gigabyte models, right? Like most of the ones that were on Hugging Face, they're just not that big. The other thing you will discover is that your indexing speed goes way down, right? But Alessandro gave a great talk, I think it was Alessandro, about when you're indexing your data, you index your documents without the enrichment just to get them into the index really quick, and then you come back later and re-index them, enabling all of the slow, expensive sentiment analysis, right? So you get your data really quick, but you get better data as that finishes. And I think we could do a lot of really cool things around like which documents are missing sentiment classification. Let's grab them and run them through the pipeline. Yeah. Especially if you're okay with that.
That would be a perfect use case for GestureJ with its forking pipelines.
Right? Yeah. So I think there's definitely some things like that to be thinking.
So with this in Lucene, can we do the Onyx models on the query set?
Yeah.
You could.
Yeah.
I mean, only some of these are applicable to the analysis chain.
100%. Yeah, sure. But some of them could be.
You wouldn't want to right now because it's slow without the GPU.
Sure.
But yeah, the GPU is nice and fast.
And expensive.
Yeah. We did debate wouldn't it be cool to have a field type called a sentiment field, and when you write the data to it, the analysis chain is just go out, do your thing, and then write the data out, right? That was also potentially when you're thinking about your data modeling, instead of having an update processor that's enriching the document, what if you had a field type that did it? And you're like, yep, copy field. You use all those things that we think about a lot, right? That was another idea that we had that might be.
This could also be maybe a secondary version of this could be using Onyx models to generate vectors inside of Solr.
Exactly.
So the vector package could also benefit from it. I mean, if there was maybe a convergent path which would say if you're using models, whether it's for NLP or for a vector generation, this is maybe a common pattern inside Solr. Now you could reference your models for generating vectors, or you want to plug it in an update processor.
Right.
So
especially some of the simpler.
I mean, embeddings. We're talking about embedding.
Yeah,
Is it real? Does OpenNLP do that?
Not right now. No.
Okay.
But there's no reason it couldn't.
I mean,
Because of the
I have
Onyx,
worked
which gives
with
you access to the underlying thing that makes the vectors. That's the thing. That's the hard thing.
Onyx models can be used for generating embeddings. I've done that.
If we can plug that in OpenNLP.
So, I mean, right now the vector module it makes you have to call and
yes, you're calling something externally.
Yeah, OpenAI or anything
Right.
externally and getting the embeddings that way, both at query and indexing time. But using an Onyx model, there is a path to making it happen. I mean, mainly out of concerns for, I mean, data governance and stuff like that. If somebody wants to generate it locally.
I was looking at the APIs just recently, right? It uses LLM for J, which in turn, or not LLM, but it uses LangChain for J, which in turn has exactly 4 things it's compatible with, and none of those 4 things is a local.
Yes,
none of
exactly.
It's not local embedding generation.
Right, which is sad. But I think it's
Question over here.
Yeah, just curious what happens inside that big processor. So when you first start initiating documents, the model is fetched from the file store and loaded into memory, and then it stays in memory. So even if you change the file in the file store, it will not affect.
Oh, fantastic.
I don't know. That sounds like file.
Probably on reload.
That sounds like an open
Probably when you
NLP
reload the
problem.
core, it
Implementation.
Does the model get loaded on the heap or on native memory?
I just took the code, refactored, and wrote a bats test. Like, I don't want to claim any more knowledge than that. I updated some dependencies and called Jeff a lot. So yeah, you gotta talk to.
I hope it's
you
not
gotta
on the
go
heap. I mean,
So,
yeah.
so we did write a unit test, but so and an integration test. So all right, yeah. Hey, we'd love to do some show and tell. I will be curious when Jenkins runs in an hour or so if there's any failures since we just merged it. But would love some feedback and happy to go through it, especially tomorrow if you're around. Would love to walk through it and play with it for people. So yeah. So all right, thanks.